Hello, my dear students of class 12. Welcome to our today's online class. I am MD Asghar Khan, Senior Lecturer, Department of Mathematics. Our running lesson plan is Dynamics from your Higher Mathematics, Chapter 9. Okay, today we want to discuss about the new exercise of this chapter is 9D. Okay, my dear student, in previous one, in 9B, already we have discussed about the particle moving along a straight line. In chapter 3, we have discussed about the moving particle through upward direction. Now, we want to discuss about the particle, if the particle moving, if the particle obtained by the particle projected from the ground with the inertial velocity u, and created angle alpha in t times is velocity b, that makes an angle theta with the horizon, and the location of the particle is at a point pxy. That means, my dear student, if you throw the particle from this position and created angle is alpha with the horizon, then horizontal line, along the horizontal line, then after time t the particle reach at a point pxy. Then you think this point, with respect this point, the velocity is b, the direction is this, and inertial velocity is direction is this. That means in this case this is called a projectile. This way is called a projectile. If you throw a particle with certain angle with the horizontal line, then the moving path is called a projectile. Okay, just you think, if you throw the particle, then we have to consider the two frame. One is horizontal line and another is vertical line. So any velocity you have to consider under the two line, horizontal line and vertical line. Just already you have know what is resolve part of any velocity. Just velocity into cosine angle of with respect of the line. If the inertial velocity is thrown in this way, created an angle alpha, then resolve part of this velocity is equal to velocity into this angle is alpha. So in angle is equal to velocity into cosine angle cos alpha. So resolve part of velocity along horizontal line is equal to u cos alpha. If you think it in a vertical line, if this angle is alpha, then this angle is 90 degree minus alpha. So along the vertical plane it will be u cos 90 degree minus alpha, then it will be u sin alpha. Just you have to know, if the particle is thrown in alpha angle with the horizontal line, then the resolve part of the velocity is u cos alpha if the velocity is u, and resolve part of the velocity along this line along this line, if along the vertical line, then u sin alpha. So any velocity along the horizontal line, resolve part is u sin alpha, along the vertical line is u sin alpha. Now we want to discuss the equation of motion by the two way. if the point is reached at a point this, and if the the velocity is b, then horizontal result part is b cos theta. If the angle is theta, then vertical result part is b sin theta. That means you have b cos theta and b sin theta. Okay, at point p x y, if the after time t. Okay, now our equation of motion, already we have no equation of motion is equal to v is equal to u minus gt, because g is gravitational acceleration which is acting at downward direction. That's why the equation of motion will be v is equal to u minus gt. For this case, projectile case, so this equation will be the velocity v is equal to according to the horizontal line, then b is equal to b cos theta, b will b cos theta, b cos alpha, b cos theta, and u is equal to u sin alpha minus z is equal to 0 into t. So b cos theta is equal to u sin alpha, because the gravitational acceleration acting at a vertical line. That's why according to the horizontal line, the gravitational acceleration is 0. So b cos theta is equal to u sin alpha. So b cos theta is equal to u, it will be, according to the horizontal line, it will be cos alpha. Cos alpha. So our formula is this. Okay. Now for the vertical line, then what will be this equation of motion? V is equal to v sin theta, and u is equal to u cos u sin, along vertical u sin alpha, minus in a vertical line, then gravitational acceleration is z. Okay, so u sin alpha into gt along the vertical line. So equation of motion is this. Now for the equation of motion, if h is equal to ut minus half of gt square along the vertical line, in this point along the horizontal line, the distance is x. So h is equal to x, u is equal to, along the horizontal line, x, u is equal to u cos alpha into t, minus along the horizontal line has no gravitational acceleration, so it will be 0. So x is equal to u cos alpha t, x is equal to u cos alpha t along horizontal line. So it moves a uniform acceleration. That's why this has no sense, and x is equal to u cos alpha into t. Okay, and vertical line, h will be y, and u is equal to, vertical u will be u sin alpha t, minus in vertical line has a gravitational acceleration, so minus half of g t square. Okay, so y is equal to u sin alpha t minus half of gt square. So my dear students, already you have learned about the equation of motion if the particle projected with alpha angle with horizon, the created angle is alpha, then what will be the equation of motion. Okay, now already in 9c, exercise 9c, already you have know what will be the greatest height if the particle throw vertically upward, then you will get the greatest height u square divided by g Now u will be u sin alpha, then the formula will be this. Okay, and because in vertical u is equal to u sin alpha, in vertical line, then u is equal to u sin alpha. Okay, then time of flight, total time of flight. If the particle throw upon this, then it will be reached at this point, and this is called the total time of flight, is equal to, in previous case, if the particle throw upward, then the 2u divided by z, and now u will be u sin alpha, okay, divided by z, and the horizontal range r is equal to u square sin 2 alpha divided by z, and time of reaching and rising at the greatest height. What is the greatest height? Greatest height in this case, just you think a vertical throw, then it will be after time t it reach this point, then this is called the greatest height h, and after this height, then the particle move in downward, then after time t it will be reached at this point. So this is the greatest height. So the time of rising at the greatest height, for the greatest height the time of rising is, in previous case already we have known u divided by z, and in this case u is equal to u sin alpha divided by z. Okay, this is our total basic concept of for this exercise 9D about the projectiles, particles. Okay, now we want to complete about the mathematical problem. Okay, my dear student, example 1, a particle projected with the same velocity at the two different angle with the horizon covers the same horizontal range r. If t1 and t2 be the two times of light, then show that r is equal to half of g t1 into t2. My dear student, if the particle is thrown with two different angle, if one angle is alpha, then another angle will be 90 degree minus alpha, because if in horizontal line, between horizontal line and vertical line, if one angle is alpha, then another angle will be 90 degree minus alpha between two horizontal line. Total angle is 90 degree, so one angle is alpha, another angle will be 90 degree minus alpha. Okay, for the alpha angle, if the particle particle through, then with alpha angle, then the time of flight is this, and horizontal range is same for both time of flight. For the both time of flight t1 and t2, the range is equal, which is r. Okay, which is r, and r is equal to this, and time of flight is this for the first throwing, if angle is alpha. Okay, this is if angle is, if the projected angle is equal to 90 degree minus alpha, then time of flight t1 is equal to u 2u sin alpha replaced by 90 degree minus alpha, and divided by g. So by the quadrant 2u cos alpha divided by z, this is the time t1, but horizontal range will be same. Now from equation 2, r is equal to, here u square sin 2 alpha, we have a trigonometric formula, sin 2 alpha is equal to 2 cos alpha, 2 sin alpha cos alpha. So u square 2 sin alpha cos alpha divided by z. Okay, we have to prove half of g t1 into t2. Okay, here t1 is this and t2 is this. Okay, this that will be the t2. Okay, so uh, we can write it for this. We want to use this formula and this. Okay, just you think u2 2u need the 2u, so u square u sin alpha u cos alpha divided by z. Okay, now we need 2u sin alpha divided by z and 2u sin alpha divided by z. Okay, 2u sin alpha divided by z, but another one is u cos alpha, and this is equal to t1 u cos alpha. Okay, now we want to use this equation, need 2u need 2 and divided by z. For this case, r is equal to t1 2u cos alpha divided by 2, for the minimize 2 divided by also 2, and we need 2u cos alpha divided by z, so multiply also by z. Okay, now t1 then g divided by 2 and 2u cos alpha divided by z. Okay, now g by 2 t1 and that will be the value of t2, 2u cos alpha divided by 2 is equal to t2, so half of g t1 t2, so therefore r is equal to this is our proved. Okay, now example 2, a particle is projected with inertial velocity u if the greatest height attained by the particle be h, then show that the range of the particle is r is equal to this. Okay, just you have this is the greatest height of this particle is h, the initial velocity is u, the horizontal result part is u cos alpha and vertical result part is u sin alpha. Okay, from according to this scenario we can write a greatest height is equal to this, and after calculation from this formula sin square alpha is equal to this and sin alpha is equal to this. Okay, we have to find the horizontal range r is equal to this, and r is equal to the formula we know that r is equal to this, and r is equal to the this expression. We have to prove this. Okay, just to think we have the value of sin alpha from the greatest height, formula of the greatest height, and then r is equal to u square divided by g. We have a trigonometric formula sin 2 alpha is equal to 2 sin alpha cos alpha, 2 sin alpha cos alpha, then r is equal to u square divided by g, and 2 sin alpha is equal to this root over 2gh divided by u square into cos alpha is equal to, we can write it 1 minus sin square alpha. Okay, so r is equal to 2u square divided by g and root over 2gh u square into 1 minus sin square. So sin alpha is equal to this and sin square alpha is equal to 2gh divided by u square, 2gh divided by u square. Okay. Now r is equal to 2u square divided by g, and 2gh divided by u square. Root over this and root over this, we can use the single root over, then multiplication of this term and this term. Okay. Is equal to in this case LCM is u square, so u square minus 2gh. Okay, so 2u square divided by g. Now from this portion we can write u4 divided by, in denominator u4, and this 2gh into u square minus 2gh. Okay, now 2u square divided by g, root over u to the power 4, it will be u square, and root over 2gh u square minus 2gh. Okay, and u square will be removed, then 2 divided by g root over 2gh into u square minus 2gh. Okay, from this calculation we have to go this. Okay, okay, here 2g and here u square divided by 2g, that means this term is divided by 2g. Okay, so r is equal to 2 divided by g and okay 2gh 2gh into u square minus 2gh. Okay, this is divided by, we need u square divided by 2g. For this we have to divide it by 2g square. We have to divide it by 4g square and into 4g square. Okay, then it will be 2g. It will be root over this is equal to 2g, so 2 divided by g into 2g, and root over for this case remove 2g, then it will be h divided by 2g and u square minus 2gh. Okay, so in this case it will be 4, so divide by 2g square, 2g in this case, so h into u square divided by 2g. Okay, then 2gh divided by 2g, then 4 root over h into, it will be u square divided by 2g minus 2 and 2 will be removed, g and g also be removed, then it will be h. So therefore r is equal to this, here r is equal to also same. R is equal to 4 into h into u square divided by 2g minus h. This is about the value of horizontal range. Okay. Okay, my dear student, this is our today's class.